In this example, I'm trying to manage a relatively complex flow through a program. I'll show how it works first, and then we'll show what it looks like behind the scenes. It's a Lotto number simulator, so you can choose to play the Lotto. You can choose how many numbers there are going to be in this Lotto. Is it going to be up to 6 numbers? Of course, it would be 6 numbers in the real world. That's going to take a while, as we'll see, so I'm just going to go with 2 numbers now. Once I've submitted that, I choose my 2 numbers, which are from 1 to 49. So remember this, 38 and 5 are my numbers. Click submit. And it took 2,881 weeks, so just picking 2 numbers before it matched. Right at the bottom here, 5 and 38. And yeah, that's how the program works. So delving into the background of that, this is pretty complex. Let's stop it and we'll have a look at what's going on. Now, you'll notice that there were 3 different templates being used. And that's just to manage the flow of the program. I could, of course, do it all with one template and one route. But then you end up with lots of if statements and nested, and it's very easy to lose track and introduce bugs into your program. So I chose to have 3 different pages as we step through, which I think is actually a really good idea for a lot of people. It just keeps it more manageable. So you end up with nice simple routes like the first one, which is just choose your 6 numbers, just returns a render template, and that index.html. I've just got a little bit of ginger code in here because I was too lazy to write out option value equals 1, option value equals 2, etc. Wouldn't even need this, but anyway, I guess it means that it's easy to update and say, oh, 8 Lotto numbers or whatever. Leave it at 7. So this form has got an action equals choose. We haven't done action before, I don't think. Basically, this just says what URL, what page to go to. So this will match our route. So this was the slash, which is the index. Typically, slash takes you to index.html. And then I've said go to choose. Now in choose, firstly I get what did they pick here in this select name equals how many, as you can see there, and that goes into there, and that goes to another simple, reasonably simple form. And just interested in why that color coding is wrong there. It worked, didn't it? But I don't see why it's gone red. Perhaps we'll come back to that. Everything looks right. Anyway, yeah, so int how many request form how many gets how many it's going to be, and then we're going to do 2 loops. One which is for the 3 or however many numbers the person wants in their the user wants in their simulation, and then up to 1 to 50 is the numbers. So I think I've butchered that a little bit, so I'll just show rather than tell. So if I choose 4 and submit, and then go Control U to see what that looks like. So we've got 1, 2, 3, and that was it. Oh, it goes 0, 1, 2, 3, doesn't it? Of course, because 0 indexed. So that's a little bit of nested ginger code to make that happen. And then finally, this again has got an action equals result, so it takes it to this route here. And let's just look at what happens in here. Firstly, now here's an interesting point. When this how many number needs to kind of bounce from one form to the next. So firstly, it's the number of numbers that we've picked. So obviously we need it here, so we show the right number of drop downs. But also we need it down here, so that when the computer chooses its weekly numbers, it's comparing the right number against the right number. So what I chose to do was I chose to pass it through here as a hidden input in this form. So if I go back to this one, you can see right at the top, I've got input type equals hidden, and I said it was going to be 4 numbers that were going to be picked. I could, of course, have done it as a global. That would work as well. No problem with doing that. I chose to do this just to show you the common use of this hidden input just to keep bouncing values through multiple forms. So we go and get that here, and we go and get each individual one of those numbers from those drop downs. So to get those, what I've chosen to do is this rest.form struct entry for it, because this is counting up numbers up to how many. So if there were 4 selected, go 0, 1, 2, 3. And I needed to have a string to index. The request.form comes through as a, I guess, a dictionary. I guess might be something different. Anyway, so that's created a list of the numbers that the user picked, and then I sort them into order. Just because it's easier to compare two sorted lists. You don't have to compare item by item. You just say, is this list equal to this list? Which we see here. So I've got 1 week numbers. It starts with the ND set. So first week we have to pick some numbers. And I've also counted the weeks, and I'm keeping track of the attempts. You saw that in the results. So I actually outputs all the guesses the computer made. And this is the comparison. I just keep looping until this week's numbers match the picked numbers from the user. So we saw that it stopped when I got 38 and 5, which were the two numbers I'd chosen. I've chosen to break this out into a little function just to make this a little bit neater. So I've made it so it's got a little array, and it picks a number from a random number between 1 and 50 and returns that value. You'd remember how to do that from level 2, hopefully. Yeah, so they all get appended into a attempts list, and then we spit it all the way back to results.html, and results.html tells us we were counting how many weeks there were. Put a space in there, keep it neat. And then I just output each one of those attempts. Let's give it one more go to see what it looks like if I go for some bigger numbers. So if I go for, say, 4, I've got to match 4 numbers now. I'm feeling lucky. So 27, 4. Remember these numbers: 4, 27, 37, and 15. Submit. And of course, it's the Lotto. So actually, no one wins the Lotto, really, or no one that you don't win the Lotto. No one that you know wins the Lotto. The odds of winning the Lotto are super, super low. As we can see, this is taking really a long time. I wasn't expecting to take it quite this long, but you know, that's the laws of probability for you. Could take a really long time. Could finish right now, or maybe now. How about now? I did have done it just now with 4 numbers, and it came up in about 5 seconds. So obviously I'm not in a lucky mood this time round. Anyway, we'll come back to that. Meanwhile, so the point of this more than anything else was just showing you multiple forms and a different idea of how to flow through those forms using multiple routes to keep your code relatively simple. This was not an easy program necessarily to write. Little snippets in there of code that, you know, this kind of thing takes time to work out how to do it, and you have to think quite a lot about how we're going to generate all of these and all of that kind of stuff. Actually, have I sorted these numbers this week? I don't think I have I? 1 week numbers. I should really have sorted these numbers. That might be why it's taking so long. Let's just stop that and add in here this week dot sort. That might make it work a bit better. Let's try again. Because like I say, I've got to compare it. Don't have to, but I'm choosing to compare a sorted list to a non-sorted list. So this time my lucky numbers are 8, 17, 40, and let's go 4. Submit. Are we going to be luckier this time around? No, maybe not. No, 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 no. Maybe I should have chosen some lower numbers. No, it's not happening, is it? Oh, it happened. So 282,000 weeks. How many years is that? It's a lot of years. Alright, there you go, done.